everyone. Today we are looking at applying exponent properties involving quotients. And you know that quotient means division, right? All right, let's take a look at a problem. If we have 8 to the 10th power divide by 8 to the 4th, the rule is when you have division and they have the exact same base, then the exponents you just subtract. So you write the same base, 8, and then do 10 minus 4, 6. So the answer to this problem is 8 to the 6th power. You can also do this for B. We have the exact same base, -3 and -3. This one's raised to the 9th to the 3rd power, so all I have to do is take 9 minus 3, put it outside the parenthesis, and then we have -3 to the 6th power. Over here, we have to multiply across the top because this division bar that's right here actually acts as a grouping symbol. So we have to work on the top first. So we get 5 to the 12th, divide by 5 to the 7th, and then we simply subtract the exponents since they have the same base. So 12 minus 7, 5. 5 to the 5th power. Now this one's interesting. We do 1 times x to the 6th, so we get x to the 6th on top equals x. And of course we have the x to the 4th on the bottom. So all they did is 1 times x to the 6th and wrote it here. And they kept x to the 4th on the bottom. Technically, we could, if you guys really wanted to, you could put this over a 1. So then multiply and you get that. Now, of course, since this is division, we take 6 minus 4. So 6 minus 4 is x to the 2nd power. All right, let's take a look at another set for you guys to do. Pause your video and try these out. All right, you should have subtracted. And so I'm going to check these answers when you guys come by, or when I come by in the morning and check your work. Let's go ahead and look at the next set. Simplify the expression. If this whole set, x and y, are raised to the 3rd power, we have x to the 3rd power and we have y to the 3rd power. Now these have different bases, so you can't subtract anything. You just have to leave it the way it is. This problem, we have to take everything inside and raise it to the 2nd power. So we have -7 to the 2nd power and x to the 2nd power. Now, -7 is a number, so we can actually multiply that out. -7 times -7 is a positive 49. And we put it over x to the 2nd, just bringing it on over. All right. Here's another example. This looks really complicated. But basically, all we have to do is take everything inside here and raise it to the 3rd power. So we take 4 to the 3rd power, x to the 2nd to the 3rd power. When we do that, there you go. Then we have to take 5 to the 3rd power and y to the 3rd power. There you go. Now the numbers can be multiplied, so we should go ahead and do that. So there, 4 to the 3rd power, 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. And notice that we have 3 times 2, so we have x to the 6th power and y to the 3rd. Well, these are actually fairly simple to do, but there's a lot of steps to remember. Just try your best. All right, part B. We have this entire term inside here has to be raised to the 5th power. And then we have times 1 to the 2a to the 2nd. Let's go ahead and work on this part first. We have a to the 2nd to the 5th, and we have b to the 5th. Remember, this whole term down here was also raised to the 5th power. We just rewrote this, brought it over. Now let's work on this. We have a to the 2nd to the 5th. That would be a to the 10th. And b to the 5th stays as b to the 5th. Now we have some basic terms. We don't have any parentheses going on, so now we can go ahead and multiply across the top. A to the 10th times 1 is a to the 10th. B to the 5th times 2a to the 2nd. Nothing matches down here. We don't have a b over here where we have to combine anything, so we're just going to rewrite these in alphabetical order. 2 times a to the 2nd, b to the 5th, just bringing them on down. Now, there's one thing that is in common from the numerator and the denominator. Look at that. A to the 10th, a to the 2nd. So we need to go ahead and subtract 10 minus 2 and keep that same base, and look what we get, a to the 8th power. And notice where it goes. It goes in the numerator. If you had had a negative number, it would go down below, but we'll get to that later. But a to the 8th stays on the top, and 2b to the 5th stays in the bottom. All right. Would you guys like to please try out these questions, pause your video, and see what you can do on your own? Welcome back. Let's see how you did. And let's check your answers. All right. Well, let's go ahead. And we're going to skip over that question, and we're going to go to example 5. Oops, I went too far in example 5. Here we go. Take a moment to read this. I'll read it aloud. The luminosity in watts of a star is the total amount of energy emitted from the star per unit of time. The order of magnitude of the luminosity of the sun is 10 to the 26 watts. Well, that's a very bright light, obviously. The star Canopus is one of the brightest stars in the sky. The order of magnitude of the luminosity of Canopus is 10 to the 30th watts. That's even brighter. How many times more luminous is Canopus than the sun? Now, this is key, is the wording here. Let me go get my little marker up here. Oops, I'm on the wrong thing. Let's see. Key words here that you need to look for in this word problem. How many times more luminous is Canopus than the sun? Then all we have to do is take 10. Well, I'll just switch sides. They write so much nicer than me. 10 to the 30th for the Canopus, because it's more, over 10 to the 26th. So all we have to do for that, obviously, is they have the exact same base, is subtract. So we get this, and we get 10 to the 4th. And so how much more luminous is Canopus? Well, Canopus is about 10 to the 4th times as luminous as the sun. Sirius is considered the brightest star in the sky. Sirius is less luminous than Canopus, but Sirius appears to be brighter because it is much closer to the Earth. The order of magnitude of luminosity of Sirius is 10 to the 28th watts. How many times more luminous is Canopus than Sirius? Pause your video and give it a try. All right, let's see how you did. It should have been 10 to the 2nd. Canopus is 10 to the 2nd times as luminous as Sirius. All right, that's it for tonight. Have a great evening. See you tomorrow.